Good morning, dear students. On our previous lesson, we were integrating trigonometric functions and irrational functions, some kind of irrationalities using trigonometric substitutions. And today our topic is definite integral. So let me remind you how to calculate them. So definite integral is calculated by Newton-Leibniz formula. So we find how to read it. So actually we find the antiderivative with substitutions from A to B, and we subtract f from B. So we subtract f from B minus f from A. And what about constant? We don't use it because anyway it will be eliminated. Here is the formula for integration by parts. So uh, it is similar to indefinite integral, but here we already use substitutions as well. So for this product UV, of course, you firstly can calculate the whole derivative and then antiderivative, and then add and then subtract. But anyway, so it looks more convenient. So now let's start calculating integrals. So basically it seems to be uh, all these integrals will be calculated during this lesson. So let's start. So first of all, calculating this integral. So from 0 to 1, square root from 1 plus x dx. So using, first of all, table of integrals, the integral will be, so antiderivative is the following. So 1 plus x, yeah, by the way, 2 over 3, because we will have a power of 3 over 2, but we need to divide by it. And substitutions from 1 to 0. So now what do we receive? So 2 over 3, then no. So 1 plus 1, so 2 square roots from 2, and minus 1, and that's it. So we calculated the integral. Any questions about this exercise?
I have a question. Where did we get 2 over 3 and times 1 plus x?
Okay, so from table of integrals, so x in power of alpha dx, so we have the following antiderivative. 1 over alpha plus 1, and x in power of alpha plus 1 plus c. Here we have power of 1 over 2, and we multiply 1, so we receive power 3 over 2. So this, and we divide by this power, and here we receive 2 over 3. So have I answered your question?
Yes, thank you.
Okay. So now more questions. Okay, if no questions, let's move to the next exercise. So the next, so integral from 0 to 2, x dx, and divided by x squared plus 1 in power of 2. So how to solve? We will use a well-known differential entry technique, first of all, because we can see in the denominator, so in the numerator, we can see the differential over this expression that in the brackets. So what we have here, so 2x dx is the differential over x squared plus 1. And then we receive 1 minus 1 over 2 multiplied by x, oh no, not this, x square plus 1. And now calculating, so using Newton-Leibniz formula. So with substitutions from 0 to 2. So minus 1 over 2. And here in the brackets, so 1 over 5 minus 1. So yeah, correct. 1 over 5 minus 1. And it will be equal, so minus 4 over 5 and 2 over 5. So multiplied by minus 1 over 2. So any questions about this exercise? Okay. If no questions, let's move to the next exercise. So C, and we have the following integral from 1 to e, 1 plus logarithm of x by x dx. Okay. So again, we will use differential entry technique. So let's differentiate 1 plus logarithms. By the way, logarithm so десятковий logarithm. So logarithm with I don't remember. So за основою 10. So you remember it. So logarithm. So such logarithms means just so the same as this. So okay. Let me remember. So if I'm not mistaken, okay. So derivative of logarithm. So not a natural logarithm. If I'm not mistaken, so we divide by natural logarithm of 10. Yeah, so yeah. So it will be the next. So x, oh, so no, 1 over x by natural logarithm of 10. So let's modify this integral. to use differential entry technique. And logarithm of 10 in the denominator. Maybe here is a mistake, it must be natural logarithm, but anyway we can calculate it. So we integrate the power function, and what we actually receive. Yeah, and yeah, so now we divide it by 2. And with the substitutions from e to 1. So from 1 to e. So let's calculate. So 1 plus nature, so 10 logarithm of x, logarithm of e, and this expression in power of 2, minus 1 minus 1, because logarithm of 1 is 0. So let's expand the brackets. So 1 plus 2 natural logarithms of e plus square of so not natural, but so logarithm from e. So we have this expression. Of course, we can expand brackets or factorize it, but anyway, this is the final answer. So this is correct. Any questions about this exercise? Okay, no questions. Let's move next to exercise D. The following integral from 1 to 2 and e in power of 1 over x divided by x square dx. So any idea how to solve it? So what do we have to do? So no idea. As well, we use differential entry technique. So what do we have? So differential over 1 over differential of 1 over x equals minus 1 over x square dx. So we have differential of 1, so minus differential of 1 over x here. So let's do the following. So minus this. So we use differential entry technique and just differentiate the integral. So it doesn't seem to be complicated. So, but yeah, don't lose signs. And we have just so such antiderivative. So with substitutions from 1 to 2, So the following. So e in power of minus 1 over 2 minus oh, stop, e in power of 1 over 2 minus e, and that's it. So any questions about this exercise? Okay, if no questions, let's move next to the next exercise. E. So we have the following integral. Here is a variable y, but anyway, so it doesn't really matter. So from 4 to 9. So y minus 1 and y square root of y plus 1. Dy. Let me look what I used here. So which approach? Yeah, so here just difference of squares. So we can do it in this case. So because no zeros, so okay. So first of all, so here is the difference of squares. So how can we write the numerator? So it looks like this. So now we cancel this, and we have the following integral. Okay, and now let's calculate the integral. So with using Newton-Leibniz formula, so we have the following expression. So 2 over 3 y square root of y minus y, and with substitutions from 4 to 9. So what do we have? 2 over 3 multiplied by 9 multiplied by 9 and multiplied by 3 minus 9 and minus 2 over 3 multiplied by 4 multiplied by 2 and minus 2. Okay, so what do we have here? So 18 minus 9, so equals, so and it can be cancelled. So 18 minus 9, so 9 in these brackets. And here, so minus uh, 16 over 3 and plus 2. Okay, let me not play with these fractions. Oh, by the way, it's not so hard. So 11 minus 16 over 3, so 33 over 3 minus 16 over 3. So it will be equal to 17 over 3. And that's the final answer. So any questions about this exercise? Okay. So if no questions, let's move next. So we have the following integral. So exercise F, integral from 0 to 1 x multiplied by e in power over minus x dx. So now we integrate by parts. So time for integration by parts. So u equals x, du equals dx. Then so dv equals e in power of minus x dx. So v equals minus e in power of minus x. And now let's integrate. So what do we receive? Minus x by e in power of minus x with the substitutions from from 0 to 1, and in this case plus integral. So from 0 to 1 e in power of minus x dx. So v du, and now let's calculate. So what about this addend? So for 0 it will be 0, and for 1, so minus e in power of minus 1, and minus, so the following integral in minus e in power of minus x with the substitutions from 0 to 1. So minus e in power of minus 1 minus e in power of minus 1 plus 1. So it equals 1 minus 2 over e. Any questions about this exercise?
No questions.
Okay, let's move next. So again, so we integrate by parts here 3 times. So integral from 0 to p, x in power of 3 multiplied by sine of x dx. So let's work. So as we see power of 3, so it means that we will integrate by parts 3 times, but a lot of components here will be eliminated. So u equals x in power of 3, du equals 3x in power of 2 dx, dv equals sine of x and dx, so v equals minus cosine of x. So let's integrate by parts. So x cube by cosine of x, and with substitutions, so from 0 to p. And okay, we have plus because minus here. So plus 3. So so plus 3 integrals from 0 to p x in power of 2 by cosine of x dx. Okay, let's again, we will integrate it by parts, and in parallel we will calculate this integral as well. Not integral, but this product. So what do we have? So integral, okay, so now u equals x square, du equals 2x dx. dv equals the cosine of x dx. So v equals sine of x. So for this product, so when x equals 0, it will be eliminated. So we have minus p cube and plus 3. So the following expression, x square over sine of multiplied by sine of x. So, and when we substitute here from 0 to p, it will be eliminated. Minus the next integral. So from 0 to p, yeah, 2 multiplied by x sine from x dx. So now less pain for us. Okay, let's expand brackets and simplify expression a little bit. So minus p cube remains. So this goes away, and minus 6 integrals. And now let's integrate by parts. Now once more. So, and it will be the last integration by parts. So u equals x, du equals dx, dv equals sine x dx, and v equals minus cosine of x. So minus p cube minus 6. So minus x cosine of x with substitutions from from 0 to p. Minus, oh no, here we have plus integral from 0 to p cosine of x dx. And let's expand and calculate. So minus p cube. Okay, we will expand a little bit later. Minus 6 multiplied by, so here we have minus p. Stop, cosine of p, just a moment. Cosine of p, what does it equal? Cosine of p is minus 1. So here is a mistake everywhere with signs. So p, and here p. I need to review table of integrals. Oh, no, not table of integrals, but values of trigonometric functions. And I recommend you the same. So we found the antiderivatives, and it is the sine of x with substitutions from 0 to p. and it is actually equal to 0. So the final answer is p cube minus 6p. So that's it. Any questions about this exercise? Okay, if no exercise or if no questions, let's move next. Uh, okay, so the next integral from 0 to e minus 1 logarithm of x plus 1 dx. Again, we use formula for integration by parts, but we have another case. So here u equals logarithm of x plus 1, and du equals 1, so dx over x plus 1. Then dv equals dx, so v equals x. And now let's calculate. So x multiplied by logarithm of x plus 1 with substitutions from 0 to e minus 1 and minus the following integral, so v du. Okay, 0 e minus 1 and here x divided by x plus 1 dx. Okay, what about this integral? So e minus 1 here will be okay. So when x equals 0, this expression will be equal to 0. So now let's calculate first of all this expression, and then we'll move to the integral. So e minus 1 multiplied by logarithm of e minus 1 plus 1 and minus this integral. So finally, not finally, of course, but currently we will receive so e minus 1 minus this integral. And now let's calculate the integral. So in the following way, we need to extract the whole part. Integer part here. So if I do the following, so 1 so we need to subtract and add 1 here. Stop. So plus and plus 1 minus 1. So if I subtract, I will receive the following expression. So 1 plus, actually it will be minus 1 of minus 1 over x plus 1. And now we can integrate because we have correct fraction. And having the following integral. So the following antiderivative will be x minus logarithm of x plus 1, and with the substitutions from 0 to e minus 1. So e minus 1 and minus so e minus 1 minus e minus 1 minus 1 And if I substitute 0, this expression will be equal to 0. So 0 minus logarithm of 1. So we have, so if we expand the brackets, we will receive only 1. And this is the final answer. Any questions about this exercise? Okay, let's move next. Part I, we have the following integral that will be calculated with the substitution of variables. So square root of x divided by square root of x minus 1 dx. We will do this substitution. So uh, how to how to do it? So let's substitute. So square root of x will be equal to t. Then x equals t square, and so dx equals 2t dt. And then what to do with the bounds of integration? Also, they will be modified. So when x equals 9, t equals 3. When x equals 4, t equals 2. And now let's rewrite the following integral. So with new bounds of integration from 2 to 3, and here what we have t square. By the way, okay, it would have been better to do the following substitution: square or root of x minus 1, then square root of okay, so square root of x minus, so x would be equal t plus 1 in power of 2, and dx would be equal to 2t plus 1 dt. And then if x equals 9, t equals 3. When x equals 4, t equals 2. So the following substitution, it would be easier, so we'll substitute completely the denominator. So from 1 to 2, then integral, so square root will be equal 1 plus t, then okay, it will be divided by t and multiplied by 2 over but multiplied by 2 t plus 1 dt. And now let's expand everything and calculate the integral. So it is actually t plus 1 in power of 2. So t square plus 2t plus 1 divided by t. Then let's expand once more. So t minus 2t and plus 1 over t. And now we integrate it. So 1 over 2 t square. Yeah, Bogdan, question?
Yeah. Why do you have minus 2t?
Yeah, so this is a mistake. Yeah.
Oh, okay.
And here plus. Yeah, so total mistake. Thank you for your attention. So 1 second t square plus 2t and plus logarithm of t. I here write without module because we know that t is always positive in this integral. So calculating. So um, in the first case, uh, so t square, so forward to, so 2 plus 2 plus logarithm of 2 and minus 1 over 2 plus 2 and plus 0. So let's expand the brackets and what we will receive. So 4 minus 2, okay, 2 minus, damn it, minus 1 over 2 and plus logarithm of 2. And now let's expand brackets. So what we will receive? So 4 minus 1, so 3 plus 2 logarithms of 2. And that's it. For definite integral, we don't have to return to old variables. So we substitute variables, we adjust bounds of integration according to new variable, and then continue integrating. Any questions about this exercise? Okay, we'll have to recalculate it. Uh, no, we'll see. Okay, yeah, here is another substitution, but it has to lead to the same result. So we'll have to recalculate this integral. So any questions for now? If no questions, let's have a break for 5 minutes and then we will continue calculating integrals. Okay, let's continue. So the next integral. So the following: the irrationality. So from uh, 3 from 3 to 8 x over square root over 1 plus x dx. So we use the following substitution. So we substitute square root of 1 plus x as t. Then so 1 plus x equals t square, and x equals t square minus 1. So dx equals 2t dt. Then what about bounds of integration? So when x equals 8, t equals 3. When x equals 3, t equals 2. Okay, now let's rewrite the new integral, rationalized integral. So from 2 to 3, so t square minus 1, um, so divided by t and multiplied by 2t dt. So we can already cancel t, and it will be much simpler than it was before. So moving to out of brackets, and we'll have t square minus 1 dt. So now let's integrate this table integral. Let's calculate this table integral, and we have 1 over 3t cube minus t, with substitutions from 2 to 3. So 1 over 3 by 27 minus 3 minus 1 over 3 by 8 by 8 minus 2. So 9 minus 9 minus 3 is 6, minus 8 over 3, and plus 2. So we have 16 minus 16 over 3. And finally, we will receive 32 over 3. So any questions about this exercise?
No questions.
Okay, if no questions, let's move next. So the following integral, k, so from 2 to 3, taking one, right, and another. So dx and divided by 2x cube plus 3x minus 2. So let's extract the perfect square here. And what we will have. Yeah, by the way, let's also move 1 over 2 out of brackets. So we will divide the denominator by 2 just to avoid a lot of irrationalities, if it's possible, of course. Uh, and by the way, it is 2 multiplied by 2 multiplied by 3 over 4. So it's a double product. So now let's calculate so let's continue extracting the perfect square. So plus 9 over 16 and minus 9 over 16. So then let's collapse it. So let's factorize. So what do we receive here? So x plus 3 over 4 in power of 2 and minus, so minus 9 over 16, so minus 25 over 16. So that's what we have. And the following integral, so it will be the table integral. Yeah, by the way, it is the differential of this expression, so nothing happens if I do this. So, and it will be the following integral. Let me remind you. So, oh, by the way, let me also look into the table integrals because I'm not confident about the sign in the denominator. Mhm. Yeah, so we will use the following integral. Uh, so dx and x, so uh, a square minus x square, and it equals natural logarithm over such module, so a plus x over a minus x plus c, and this expression is multiplied by 1 over 2. Here we have so another order, so let's uh, use minus here, and then we write our fraction. So a equals 5 over 4 in this case. So 5 over 4 minus plus x plus 3 over 4. And in the denominator, 5 over 4 minus x minus 3 over 4. And with substitutions, yes, such a large expression. So with the substitutions from 2 to 3. So now let's simplify this expression a little bit. So both numerator and denominator. So 2 plus x. And here what do we have? 1 over 2 minus x. So Okay, so now let's use Newton-Leibniz formula. Okay, so minus 1 over 2, and now substitute values. So from 2 to 1. So first of all, logarithm over so 5, and here so the model is the following. So 1 over 2 so 3 minus 1 over 2, and 3 minus 1 over 2 equals 5 over 2, and then minus logarithm over 4 divided by 3 over 2. And of course, we can uh, simplify a little bit this expression. So minus, let's simplify, yeah, minus 1 over 2. Or we can move minus here, and we just will change the sign. So reminding you that difference of logarithms equals logarithm over fraction. Uh, so 5 over 2 and 3 over 2. Okay, let me rewrite it into a more convenient way, more understandable. Yeah, not to the fractions. So 3 over 2 and multiplied by 5. So 2 goes away. And 5 as well goes away, but let's write it in the next iteration. So 1 second logarithm over 4 over 3. So now not such a huge expression. Any questions about this exercise?
Yeah, I've got a question. Where did the minus in front of 1 over 2 come from?
Yeah, answering your question, yeah. Okay, I skipped this step, but let me write it yeah, let me write it. So, I just changed the order of this, so in this difference. So changed, so multiplied denominator by -1, and what I received. So that's where minus appeared. And for table integral, we have the following expression. So 1 over a cube minus x cube. So just so to transform to table form of the integral. Have I answered your question?
Oh, yeah. Yeah, thank you a lot.
More questions? Yeah, so that's why you shouldn't skip steps when doing your individual tasks. As you see, as everyone see, it's not always good. So it can cause some mistakes or misunderstanding. Okay, I will skip L because I don't actually like extract an integer part and so on. Actually, so this is integration of a rational fraction that you already know. And now let's move to M and remember method of undetermined coefficients a little bit. So from 0 to a over 2, and integral from a dx. So a is just a real number. We don't know what's the number, but a number. We don't know either it is positive or negative. It doesn't matter us. So using undetermined coefficients method. So a capital over x minus a plus b over x minus 2a. So a capital A multiplied by x minus 2a plus b multiplied by x minus a. Let's expand the brackets. So yes, so not a lot of coefficients. That is good. It means that we will calculate everything fast. Yeah, a little bit misunderstanding with the coefficients. Yeah, maybe it is better to use C, for example. Yeah, let's do it. So capitals, small letters. So now let's regroup. So B plus C x and plus so minus 2 minus a minus 2a stop minus 2a b minus 2a to ac. Okay, so having the following system of linear equations. So b plus c equals 0, and this expression equals a. So let's uh, divide the second equation by a. So we suppose that a is not equal to 0 because integral from 0 to 0 equals 0. And also, so let's divide it by minus a. So b plus 2c equals minus 1. If I subtract the uh, first equation from the second, I will receive so mm, so 0b, so c equals minus 1. Then b equals 1. Okay, so let's write down the integral. So the following integral, yeah, let me copy and paste, and then we'll remove what we don't need. Minus here and plus here. Yeah, be careful with B and C because so we use such coefficients. So a little bit incorrect order, so not by the alphabet, but anyway, it will not affect the final result. So logarithm of module x minus 2a from 2 to a over 2 minus logarithm of module x minus a. From 0 to a over 2. So calculating the first integral, so logarithm of, so when a over 2, so logarithm of, okay, modules, so a over, so 3 over 2a minus logarithm over module of 2a, then minus a logarithm of 1 over 2a, and plus logarithm of module a. Okay, now let's simplify it a little bit, so we have the following fraction. So using properties of logarithm difference and sum. So, okay, let me plug in my laptop. Mhm. So 3 over 2a square, and dividing it by 2 over 1 multiplied by 1 over 2a cube or a square. Then, so what can we see? So a square, first of all, goes away. So let's cancel it. Then 1 over 2. Okay, here I have just 1. So a logarithm of 3 over 2. Because we have 1 here. So this expression does not depend on a. Any questions about this exercise? Okay, if no questions, let's move to n. So we have such a trigonometric expression. So cosine of x in power of 5 multiplied by sine over 2x dx. So as we know from the previous lesson, we can simplify it using such trigonometric formulas. So sine of, let me remind you that sine of 2x equals 2 sine of x multiplied by cosine of x. So doing the same to this integral. So sine of x and multiplied by cosine of x. Now let's use differential entry technique. So sine of x dx equals minus differential of cosine of x. So minus minus cosine of x in power of 2 and in power of 6 and by the differential over cosine of x. So now we just use the table of integrals. So minus 2 over 7 cosine of x in power of 7 with substitutions from 0 to p over 2. So 0 and half of p. So cosine of 2 over 7 cosine of p over 2 is 0, so 0 minus 1. Cosine of 0 is always 1. So it equals 2 over 7. So such a simple integral. Any questions about this exercise? Okay, if no questions, let's solve the last exercise for today. So integral all. So the following integral, irrational function as we like. So 1 minus x square and this expression in power of 3 dx. As we remember from the previous lesson, it can be solved with using trigonometric substitutions. And for such a case, as we remember, we can use trigonometric substitution like so x. So let me remind you. Okay, so in this case, we use substitution x equals sine of t. Yeah, by the way, let's start using it. So let's write everything that we need here. So okay, x equals sine of t, then dx equals cosine of t dt. Then t equals arc sine of t equals arc sine of x. Then when x equals 1, t equals p over 2. When x equals 0, t equals 0. So now let's calculate the new integral. So rationalized. Okay, rationalized is not correct definition here, but anyway. So 1 minus x. So we have cosine in power of 6 dx, so under the root, and multiplied by cosine of x dx. So yeah, we will have to use, so we will have to reduce it degree-wise because we have cosine in power of 4x. Yeah, by the way, new bounds of integration. So p over 2 and here p over 2 as well. Yeah, and t. Now no x, only t. So uh, okay, cosine. Yeah, let me remind you that cosine square over t equals 1 over, so 1 plus cosine over 2t over divided by 2. So I'm moving 1 over 4 out of brackets, and I receive 1 plus cosine over 2t here, and what do we receive? Then let's expand the brackets. So 1 plus 2 cosine over 2t plus uh, cosine square over 2t dt. Again, using degree reduced formula. So plus 1 plus 1 over 2. Yeah, using wrong hotkeys. And plus over 2 cosine over 40 dt. So having the following integral. So now we can integrate it, yeah, but yeah, let's also add 1 and 1 over 2. So we have 3 over 2. And let's move it to the beginning. So we have the following following substitutions. So using Newton-Leibniz formula now, 3 over 2 t plus sine over 2t and plus stop 1 over 2 here, and here 1 over 2 plus 1 over 8 sine over 4t. And this expression will be simplified. A lot of addends will be eliminated. So sine of 2t, so with substitution of p over 2, so this is sine over p, and it equal to 0. Sine of 0 is always equal to 0. Sine of 2p equals to 0. So now what interests us only this addend, and when t equals 0, it is also equal to 0. So what do we have? 1 over 4 multiplied by 3. What's going on? Multiplied by 3 over 2, and multiplied by p over 2. And what do we actually have? So 3p over 16. And that's it. Any questions about this exercise? About the whole lesson? About previous lessons? So,
Sorry, I actually have a question.
yeah,
Do you keep making recording of our lessons?
just a moment. It should be.
Because I wanted to find the recording of previous lesson on
Ah,
YouTube, but I couldn't.
yeah, maybe it was a wrong link. I corrected it at the weekend. So video of lessons, and so another playlist. So for the second semester, other playlist.
Okay, Yeah,
Yes,
I think I used the wrong one. So
yeah,
yeah.
yeah. So this link was copied and pasted from the previous semester. So yeah, a little bit confusable. I just noticed it yesterday. So now, yeah, just not to mix everything up. Uh, so different playlists for different semesters. Um, more questions? Okay, if no questions, let's finish the lesson. Have a nice day, stay safe, goodbye. Thank you for your attention.
Thank you.
Thank
Goodbye.
you.
Have a nice
Goodbye.
day.
Thank you a lot.
Bye. Have a nice
Take
day.
care.
Bye.